Okay, this is another example we will use to solidify the concept of internal loading. So internal loading, example 2. Okay. They want us to find the internal loading at C. Okay, so in order to solve that, we're going to make our cut at C. When we make our cut, we have a choice to either use left section or right section. Which one you think is easier? Yep, I think the left section will be easier because you don't have distributed load. So, however, we do need to find our reaction support at A though. So we need using our FBD number 1, this entire beam, to figure out the reaction at A. It's a pin support, so we have AX and AY. So this is our AY, and we also have our AX. And for B, we'll only have BY. Okay, so first equation, forces at X direction, that will give us AX equal to 0. And forces at Y direction, we'll have AY going upward and the 7.5 going downward. And we have distributed load is rectangle, so 1.8 times, what's the distance here? Is at 2.5, right? 3 minus 0.5, so times 2.5, and that's going downward. Then we'll have our BY equals 0. Well, after I wrote this equation, I realized I really just want to find AY, right? I don't really need to find BY. So I don't even need to write down this equation. It's optional. Because if I use moment about B, I can find AY directly. So AY times this entire beam, that's 5 meters, that's moment of arm, clockwise, so that's negative. Then we have 7.5 times the moment of arm from here to here, that will give us 4, and it's counter, so it's positive. Then we're going to find the equivalent of this distributed load, which is 1.8 times 2.5, right? And put into calculator, that gave us 4.5 kilonewton, and that happened to be distance here. How far is that? Would that be 1.25? Because it's going to be half of 2.5. Okay. So knowing that, so we're going to write down 4.5 kilonewton times 1.25. That's moment of arm, and it's counterclockwise, so it's plus. Then BY going through point B, so that will not show up in the equation, equal to 0. So from this equation, we can find our AY. So I'm putting my calculator. So I have 7.125 kilonewton for AY. Okay. So once I have that, we are going to look at our section, use a method of section to solve the internal loading. So FBD number 2. Like we have brainstormed earlier, we decided to go ahead using the left section here. So in order to do that, our FBD will look like this. This is where we cut. And for this FBD, what do we have? We have this 7.5 kilonewton at the midpoint of this section. Then we also solved AY. It's going upward as 7.125 kilonewton. Then that's our external loading. How about internal loading? So we're reviewing the internal loading. Using the sign convention, tension perpendicular have to be normal and have to be make it tension, right? The normal have to be in tension, so that's going to be N, pulling apart. And then we also have shear. Shear is going to make this entire structure to rotate clockwise. So in order to do that, shear have to be parallel to the surface. So it's going to be up and down, and here to make it clockwise, it's going to go down, so that's V. Also, bending moment, we're going to make this beam to bend like a happy smile. So in order to do that, that's going to be bending like this. So that's our 3 unknowns. Okay, so now we're going to write down our equations. So forces at x direction, you already seen this before. That's just going to give us normal force equal to 0 because there's no other external horizontal forces, right? So we have forces at y, then we'll have upward force 7.125 going up. Then we'll also have this going downward, negative 7.5. Then we'll also have the shear force. It's happened to be going downward for this one. That equals 0. So that will give us our shear force equal to so let's see. It's going to be negative 0.375 kilonewton. Okay, now we're going to solve our bending moment. And remember, we always do moment about where we cut. So moment about where we cut. So 7.125, what's moment of arm for that one? This entire beam is 2 meters, so times 2 meters. And that make a clockwise rotation, it's negative. Then we have this 7.5 times moment of arm for here, it's 1 meter times 1, that's counterclockwise, so it's positive. Then we'll have this moment. This moment is happen to be counterclockwise, so that's going to be plus m. That equals 0. Okay, so then we can solve this bending moment, m. So put into calculator. I have 6.75 kilonewton meter. So that's our bending moment at point C. So we solve everything. All right, so that will be end of the second example for internal loading. Hope you enjoy your day and see you next time.